Welcome to Voices of Video. As we head toward NAB, we are speaking with partners across the VPU ecosystem about the questions that quietly determine whether video systems succeed or fail. Today's episode is called When Benchmarks Lie, How Video Teams Misread Efficiency. Because if you think about it, in modern video infrastructure, disagreement rarely starts with architecture diagrams. It starts with numbers. We are joined by Juan Casal, partner and chief R&D officer at Ceres21. Juan's career spans more than 2 decades of building video technology at every layer, from developing encoding algorithms and working directly with hardware acceleration APIs, to designing high-density transcoding system and contributing to large-scale European R&D initiatives. He has worked across CPUs, GPUs, purpose-built accelerators, and real-time delivery systems. That breadth matters because measurement only makes sense if you understand how systems actually behave under load. Juan, great to have you with us.
Thank you. Thank you, Anita.
Moderating today's discussion is Leonardo Nito, Director of Market Development at EMEA at NetInt. Leo approaches this conversation from the market side. This way, he's able to surface the recurring evaluation mistakes, architectural tensions, and scaling blind spots he hears from teams making real deployment decisions. Leo, over to you.
Thank you, Anita, and great having you, Juan. It's always great to make these sessions so that our audience can chip in and ask more questions or challenge what we are saying here. But it's always good to keep these conversations open. Just to try to solve very complex problems in a ever growing industry.
Thank you, Leonardo. Yes.
So we start first. When as the title of this session says, one pattern that I consistently see across teams is that everything appears stable in staging. The numbers say one thing, but when things actually they reach production, there's always unexpected behavior that begin to surface, and gathering sometimes data might not be as accurate as one think it is. What changes once a video system moves from a control environment into real production, like start from the ground up? What can you tell me about that?
I would say that what the biggest change is variability. And when you go into production, variability is the real stress test. Because you usually test your technology in the staging, let's say, and this means a controlled environment and a stable network, a stable hardware, and well formatted content. There we always try to simulate the conditions of a production environment. But this is very difficult because what really takes variability in a production environment is scale. Okay, when you deploy at scale, equipments are interactive. There's interaction in the network at the different stages, and this is what brings variability into the moment. So at the scales, at the end, new constraints apply. So there are thermal problems that you don't usually have in the staging. There are input-output bottlenecks. There are memory pressure, and everything is unexpected. Well, at this point, you go into production, and complexity becomes a liability. Okay, because every new stage in the pipeline multiplies the potential failure paths.
No, understood. Because I understand the issue is not the benchmarks are wrong. It's a lot of variables to take into consideration, and they are. Systems are many pieces running together, and they operate, like you say, under very random variable constraints, things that one might think one has control on. But ultimately, once you are live on the field, these unexpected things happen. Let's dive a little deeper into that, because that's the context of what we're talking about. A lot of evaluations, they isolate components. Well, because logically, I mean, it's the first approach, the natural approach, to try to enumerate a panoply of different variables, let's call them. Encoder throughput, codec efficiency, I don't know, quality of experience, instance costs, you name it. And as you say, these systems operate, as a whole, almost like an orchestra, right? First, how important is it to evaluate the full pipeline rather than optimizing individual components as an initial approach?
Okay, I would say that this is fundamental. I mean, this is a key task that it should be always done. I mean, video systems are composed, as we know, of a pipeline of different components. Usually, there's an ingest, there's a preprocessor, encoder, packager, there's transmission, decoding, and rendering. Okay, when video system works properly and works smooth, and so that user's experience is smooth and is very good, it usually means that there's a balance in the way all of those components are working. So it doesn't necessarily mean that every of those components is super highly optimized.
Mm-hmm.
But there is a balance, what makes the system work properly and take a very good user experience to the customer.
Interesting, but in your experience, how often does improving, let's say, a single stage, or let's say a single component, increases the risk of affecting that that entire workflow? Because oftentimes people might point out, maybe it's the problem with the FPGA encoder. Oh no, maybe it's the way how the codec itself is not responding to, to certain frames, depending on the utility as well, of course. But do you feel, or how do you feel that, let's say, fixing only one, and focusing on that affects the entire vision of what one is doing?
I think that's quite a common issue in video systems, because whenever you optimize one of the stages of the system,
Mm-hmm.
this can shift, let's say, load pressure to later stages in the pipeline. An example of this could be that if you use a higher optimized tools for encoding, then you may need a more powerful decoder to decode that video stream, so that you have increased your encoding quality, maybe even decrease the size of the stream. But when you take it to your decoder, the decoder needs more processing power
Of
that
course.
it may have, which may lead to frame dropping and worse user experience. Local optimization often shifts load rather than removing it, in a way of speaking. This can also happen, for example, was related to encoding and decoding, but optimizing encoding can also lead to higher network burst, which also can take to a worse quality of experience for the customer, and these kind of things happen. So at the end, whenever you optimize one of your components, you have to understand first if this is an optimization for your system, for your use
Correct.
case,
Mm-hmm.
and how this may affect to the other components of the system. Other way, you may degrade the quality of experience.
Correct. I understand. Obviously, as you say, there's always a context. These things have to happen within a certain set of realities and objectives that we're doing. This brings us, I suppose, to, I guess, the necessity for at least be confident on the predictability of set orchestrations. I hear many teams say that peak performance is impressive, that we can do so many great things at each individual level. But of course, if all those things are working perfectly, but together they create, I guess you could say, a cacophony of processes, and that does not achieve what you're doing. In which context or how can we build that predictability? Because in the end, let's say, to get all these things organized, processes that are very complex, in the end, fundamentally, they will never be perfect, but at least they have to yield a level of confidence that can make the operators feel, look, all right, we might not know, but we can definitely bet that it's going to work this way. So what enables, that operational confidence? Why is predictability more valuable than just, peak benchmark numbers, and what it means to what we're doing?
Sure, this happens. Sure, predictability is a main fact that we need on when operating video systems. That's for sure. Because when in operations, what you want guarantees. So you don't relate to, let's say, marketing numbers. Okay, this is very good in some feature, but at the end, as we said, we want stability. We want something that we can guess how it will work in the under different conditions. Something that we want whenever we go to production and variability happens, or we go for worse conditions. Let's say is able to absorb some of those worse conditions. Okay, so what do teams value? Really value? They want to have a limited latency. That's sure. They want to know what their latency is going to be and how it will behave over time. They want a stable resource usage, so that they can guess if I have 3 stream and I'm working at 60% of my capacity. If I put a new 4th stream, I will be around 80% of my capacity. This is predictability, and this is what really makes you able to plan capacity of your system when you go in production. Okay, so at the end, I may say that in production, the worst case behavior matters more than the best case behavior.
If maybe a question just to create a benchmark. Well, the question is, if two systems show similar average throughput, but at the end the result shows a very different variance, like one performs better than the other, but all parameters are relatively similar. How should teams interpret that? What can they do, and what does that mean for real deployment decisions?
Under those conditions, I would guess. I think that there's a big unless you have good observation tools and you have your system properly designed against failure, whenever you go to production and you go up at scale, I guess that it will be very difficult to find why one of them is underperforming against the other. When if you have quite similar, let's say, benchmarks in the components. But I would guess that there's some. I think that this question is related as well to the stability of the system, so that I will guess that there is some component creating an instability, or you can have some issues that as maybe jitter, maybe buffers underflows because of network burst, or these kind of things. But what is for sure is that if you don't have your system designed for failure prediction, let's say, it will be very difficult to understand what's really happening in your system.
Understood. From your perspective, in that case, what are some small evaluation choices that teams underestimate and that later become significant problems? As you mentioned, you have to have eyes, across the board. And as we mentioned before, the averages can look similar, and it's rather difficult to interpret. But from your perspective,
I think that the most dangerous issues that we underestimate are usually metric and observability gaps. I mean, it's about the same, but when you deploy a system, you need to know what's the latency you have to measure. You have to measure peaks instead of averages. You have to take jitter into account. You have to take and align the timestamps into account, and to be able to characterize bottlenecks in the network. Let's say these kind of things, because when you are testing in staging, so in a smaller scale, these kind of errors usually don't lead to a very bad experience, user experience, let's say, and they are quite easy to find, or let's say not that difficult to find. But when you go at scale, these kind of issues are amplified, and so everything gets a mess, and it is very difficult to know the source of the problem, or which state of the system is the source of the problem, which stage of the system is amplifying the problem, and which is not affecting, and which one is not affecting at all. So the only way to do that is to have good metrics, to be able to characterize the main video metrics, as we have said, jitter, timestamps, a proper format, a proper content format, without errors and these kind of things, so that when there's an issue, you can relate the issue with some metric.
And to that, this was all in the hypothetical sense. Do you have any examples of, or an anecdote to share with us where, everything looked well on the metrics, on the lab reports, but then later, caused some issues? Something that you are comfortable to share as an anecdote from a practical sense.
I think there are plenty. Depends on the technology, sure, but I mean, when you relate to, let's say, if you relate to broadcast, where clock accuracy is important, or IPTV, where with the low delay IPTV, where clock accuracy is very important, and it's very difficult to measure the jitter at that scale, because it is nanoseconds of jitter may affect the quality of your decoding, and this is very whenever there's a, let's say, the network condition that changes a bit how the traffic behaves. This takes you in the decoder to higher jitter, what at the end makes the decoder lose some frames, and so give a user experience as if the video is failing.
It sounds like a lot of these failures, or they might not necessarily be attributed to hardware limitations. It could be interpretation errors. Efficiency is often discussed as cost per stream or streams per server. But in real deployments, efficiency shows up in different ways. How does efficiency, in your opinion, appear operationally beyond simple cost savings?
Well, in my opinion, efficiency creates headroom. I mean, so it gives you confidence for your video service, for your video system. Lower power consumption reduces thermal stress, or lower computational needs reduces contention at the end. So everything is related when we think about efficiency. Operationally, efficiency means more stability, better behavior against network burst, and less saturation, and higher saturation thresholds. Okay. So, in my opinion, it is not everything about cost saving, but efficiency buys time and margin. It allows you to have more confidence in your system, and it allows your system to absorb variability and reduce instability.
Yeah, I agree. I agree. It's not just about a compression ratio. It's not about just power savings. Everything has to, evolve towards that same goal. And
yes, so it's not about cost
it's
per
not
stream, but it's more about how close you operate from your failure boundary. Let's
correct.
say.
And this brings us, teams introduce purpose-built accelerators. I mean, we're not going to talk too much about that because the point of this discussion is not to mention us too much, but alongside GPUs, CPUs, does that change how efficiency should be measured just when you have accelerators? Because I mean, it's a very crucial point in any video distribution system. But right now, this is the big question. CPUs or GPUs, even if PGAs are not necessarily able to keep up to this growing video demand, this scalability challenges. And obviously, there's new technologies, new solutions that come into the question. Obviously, there's a lot of tests and everything, a lot of, like you mentioned earlier, a lot of things to consider. Let's just leave it at that. But let's say, since it's not just about compression or throughput, and also about margin, about control of costs, etc. If a team is preparing today to deploy a production video system for the first time, just to keep it, let's bring it back to the ground, something very hypothetical, but people are doing this today. What is one thing you will encourage them not to overlook, as just to leave the key takeaway for everybody and leave the door open to come talk to us at NAB? Of course, talk to the teams at Cirrus, because you guys have obviously a very, very sensible approach to fixing this. So what do you think about this one?
More than encouraging them not to overlook, what I will encourage them is to design for observability and control failure from day one. I mean, I think that's the main focus you should have when designing a video system. You should know where your bottlenecks form, how your latency evolves over time, how the system degrades, and maybe what your capacity limits are. Yeah, and what your capacity limits are. Okay. So a good recommendation on this would be, let's say, to test under sustained load, not just under peaks, because sometimes when you are testing a system, you try to push put the system under pressure, and you try to make tests a lot of bursters and these kind of things. But sometimes components are able to absorb those kind of bursts. So real problems may occur more when you're working on a sustainable load. Okay. So what I would say is that operating a system is more about predicting failures than to reacting to them. So that's why observability and so on is that important. Okay.
Right. Well, thank you for all your savoir-faire. What we take from this, obviously, is that, benchmarks rarely fail because, they're inaccurate. There's always a context in which we have to also consider the data that we're reading from, that we're applying it on. And, when systems scale and incorporate specialized compute, measurement becomes a design discipline. And it certainly shapes architectural decisions rather than reporting results. And obviously, it's a much more comprehensive approach is needed. Since we're doing this before NAB, I hope that people listening to this, you guys are invited to come see us at NAB on our booth. It doesn't have to be, obviously, a commercial discussion, but we always like to keep these these musings alive, because there's always challenges to resolve. And I think we have experts here that have not just a sensible approach, but I think a sensible one. Thank you for a technically grounded and very practical discussion. And we hope to see you guys soon at NAB.
Okay, thank you very much. I hope to see you guys as well.
Indeed.
Thank you both. Juan, I repeat after Leo. What stands out in this discussion is that benchmarks don't fail because they are inaccurate. They fail because they are incomplete.
Yeah.
Leo, thank you for consistently pushing the conversation beyond which number is higher toward what those numbers actually mean in production. For teams preparing for NAB, this is the real shift happening in the industry. Efficiency is no longer just about throughput, it's about stability, comparability, and confidence under sustained load. Because in the end, infrastructure decisions are rarely reversed in spreadsheets. They are reversed in production. Thanks to everyone listening, and we'll see you at the next Voices of Video.